So first of all, thanks to Alexi and Mason and AI by the Bay for inviting us to talk to you today. My name is Christopher Heiser. I'm the co-founder and CEO of Renovo. We are a company that's focused on automated mobility on demand. We're going to talk a little bit about what that means to us and how it affects the way we think about vehicle design and systems design. So I think what's important to think about right now is that automation is a relatively poorly understood field. If it were understood, people would have commercialized the product by now. And there's a lot of different approaches. There's a lot of different even agreement on what sensors are going to be used, how they're going to be deployed, who's going to control them. None of this is really understood. But the goal is to actually get this to scale. That once we operate these fleets in hundreds or thousands or tens of thousands of vehicles in cities, it transforms a lot of important things. We'll talk a little bit about that, but I want to get into some detail as we go along. A little bit about us as a company. We're based here in the Silicon Valley. We are a team of technologists, some of us with backgrounds from big companies here in the Silicon Valley. And we are thinking about how what we've been working on over our careers affects the vehicle. We're also very deep into cars. We understand safety critical systems at a low level. We build all of our own prototypes in-house. We're very self-sufficient, and that's important because, as we're going to talk about in a bit here, automating the car is actually a collision of two very different worlds, and they don't speak the same language. There's a sort of massive impedance mismatch between these two organizations, automotive and self-driving. So that's one of the things that we focus on. We also test a lot, and we like to find test environments that are very extreme. So we'll show a brief clip from one of those test programs. This is the partnership with Stanford. Stanford is doing research to figure out how self-driving can improve safety by controlling cars at the limit of traction. So as we can teach cars to handle vehicles outside of normal conditions, we can prevent more accidents. And so this is a program that we work on with Stanford. This is Marty, and it is a self-driving DeLorean. And so this is Adam Savage's first ride in it from Mythbusters. And it takes us about 90 seconds to boil a set of tires off of Marty. So the test is mostly us changing tires than anything else. But the point is that in these environments, small errors result in massive problems. So when you're driving at 10 miles an hour on a city street, if you make an error, there's lots of time to change that. You can run your autonomous loops as slow as maybe 50 or 100 hertz. In this environment, if you make a tiny error, the car spins out of control. So we like these environments because it pushes our technology and our systems to the limit and allows us to think about how it's going to affect systems like this, Shanghai, 24 million people. So the types of things that you see on a skid pad in a city are very different. But at some level of the system, it begins to look the same. And that interface between these two worlds is a big focus of our company. So a tiny little bit about me. I went to Carnegie Mellon. I worked on robotics when I was there. I worked at IDEO product development down in Palo Alto, building really cool products. I worked on pioneering the camera phone. So I love disruptive businesses. But unlike most people in the self-driving car world, I actually like driving. I really enjoy it. It's fun. I do it to clear my head. And I don't want to sound like it's a nostalgia thing. More importantly, driving or the freedom to move from place to place, I think is very fundamental. And when you look at societies that are becoming developed nations, it's one of the first things that people reach out to. Some of the greatest growth for automobiles is not in the US. It's certainly not in Europe, where GM is about to divest itself of its entire car business there to Peugeot. It's in places like China and India. So driving is something that speaks to a freedom that we have, and a lot of the people at Renovo really identify with that. And one of the things we're trying to figure out is, how does that translate to a car that you may not drive or you may not even own? That's a very interesting problem as well. Because I enjoy driving and racing, I'm attracted to figuring out how these two things work together. So I'm a founding advisor to self-racing cars created by Joshua Schachter. So you probably may have heard about this earlier in the talk today, so I won't dwell on it too much, except to say that the real beauty of this is It is a grassroots movement. It's an autonomous racing competition that's designed to make things inexpensive and easy for people to do. So if you are a researcher in AI or you're working on anything to do with automated systems, come to the event. There's an event early next month. We'd love to have you out there. You'll see lots of cool stuff. You may even find applications for the things that you're working on. But what I think is more interesting about this is that it's a sort of a counter to RoboRace or some of the very expensive systems that only a few groups will get to work at. Joshua is dedicated to making this be something that's going to be accessible to everybody, hopefully even down to high school level. So that's super exciting. So self-racing cars, it's on the web. So one of the exciting things about addressing a technical group of people is that you all use logic and math and reason on a regular basis. So what we're going to do is we're actually going to reason why the AMOD car is not only the apex of what we should be working on, but kind of the only thing we should be thinking about long term. So now, unfortunately, that means audience participation. So hopefully people aren't too uncomfortable with that. So let's start with just briefly defining what we mean. You've probably seen this chart earlier today. If you haven't, I apologize for my previous speakers. This is the self-driving automation scale for cars. When you hear level 1, level 2, level 5, that's what this means. We'll put a PDF of the deck with Alexi so you guys can get this. But the bottom line is that when people talk about fully autonomous cars or self-driving cars, what they're really saying is highly automated vehicles. And in the SAE standard, which is now pretty much being adopted by everyone in the world, that means level 4 and level 5. And the critical thing is that this means the human is not in the loop. And there's a little subtlety of difference between level 4 and level 5. In level 4, the vehicle can ask the human to intervene, but the human's not required to intervene, whereas in level 5, it's expected that the human is never asked to intervene. So when we talk about it, we try not to use the words autonomous. We try to talk about automation, because autonomy really has to do with choice, and automation has to do with repeating a process accurately to a specification. You don't want an autonomous coffee maker that chats you up and decides that you'd rather like your latte a little bit differently today than yesterday. You want an automated coffee machine that makes it the way you want it on demand. So this is really important, and you'll see that in the technical information and the specifications, people get very, very specific about the difference between these two. So we're focused on high levels of automation. So just by a show of hands, who believes that this is a bounded problem that we can solve? We can have a car drive itself automated. You guys should all be optimists because you're in AI, so please raise your hand. So hopefully it is. What's interesting about this is that even in the 1960s, people understood what the hard problems were. They said, hey, this thing's going to drive on this magnetic track, and RCA is going to beam radio waves down to it. But when you get to an intersection, you're going to have to take over and steer it. And I thought that was kind of interesting, that even 50 years ago, 60 years ago, people understood some of the conceptual problems with driving and what would be hard and what would be easy. So it's a bounded problem. And I think if you're George Hotz, your argument is that it's bounded by the power of a cell phone. If you're Danny in NVIDIA, you're hoping it's a trunk load of PX2s. But either way, it's somewhere in between these two worlds that the computing power is there, and the advancements in machine learning, particularly with object classification and vision processing, have made things a lot better today than they were 5 or 10 years ago. So we kind of see a light at the end of the tunnel. So will automated systems be better than humans? So once we've built these systems and we trained them, who thinks in the aggregate these systems will have fewer and less serious crashes and incidents than humans? Okay, good. That's awesome. So you're right. And the important thing to think about, by the way, the fun bit about this, I don't know if this is Total Recall, movie 1990, probably is older than some of you here. There's a fantastic scene where he's driving around and sort of conversing with this robot, and in the end, Arnold decides not to pay, and the robot tries to kill him. So this really is an autonomous system in the fact that it decides to go after the people inside of it. But anyway, there's a fantastic article in the Atlantic from 3 or 4 days ago about how AI is really like what people think AI is in the movies. And I think some people, self-driving is what self-driving is in the movies. It's Minority Report, it's this, but anyway. So the good news is that most of the problems that happen on roads are due to people anyway. So if you fix that problem, You solve the vast majority of injury and death on the roads. By the way, 1 million people, over 1 million every year, die of road injury globally. It's one of the top 10 killers of humanity, amongst with cancer and other diseases. But more importantly, most of these crashes are not someone was coming, it's not a trolley problem. People know what a trolley problem is, right? That's not it. There's not thousands and thousands of trolley problems. There's not thousands and thousands of you came to an intersection and a boat was crashing down and there was a blimp exploding. It's not that. You were texting, you fell asleep, you had too many drinks, you were yelling at your kids. That's what happens. Automated systems, unless you ask them to, are not going to yell at your kids. They're not going to make these kinds of simple, unforced errors that humans make all the time. We're really good at driving at a kind of a minimum level across lots of platforms, but we're actually kind of crappy at driving. And these automated systems are going to fix a lot of that. So great, so it's a bounded problem and the robots will be better than us. So once we've achieved that level, who thinks that having a car that also allows you to drive it, in addition to you driving it, will be more expensive than one that just drives itself? Okay, so people raise your hands. You're seeing a pattern here. Yes is always the answer. Yes, because it's really expensive to do this. As soon as you put humans in the loop, you have safety critical systems that you have to design, that you have to validate, that you have to build crash structures around, that you have to integrate into the cabin. Pedals, steering wheels, buttons, knobs, displays. That center console is an ASIL rated device. That means that it takes about 2.5 years to design and build it, and you cannot really change it that much once it gets into production. There's some companies like Tesla that are pushing quite hard on this, but if you ask people at the major OEs, they say don't touch the cluster because it's so critical to the safety function of the driver. This is a big problem. It's a lot of cost. And if you're just driving autonomously, it is dead weight. And more importantly, it's expense, which means that adoption is slow. If you look inside the Waymo car, there's nothing inside it to drive. Now, not true exactly. They can take the center console out and stick a steering wheel in there, and they do from time to time. And if you see the little slot down near the footwell, you can plug in brake pedals and gas pedals. But Waymo built a vehicle that could be seen as a fully level 5 A-mod car. And it doesn't have any of that. There are other people that have experimented with this idea. This is Rolls-Royce. This is sort of the opposite end of the spectrum from the Waymo Koala car. This is a, I think 5-meter long luxury sedan. But all it has is super comfy seats and a really awesome TV in the front of it. By the way, this is the reason why a lot of other companies are interested in A-mod, because they get to put what's on that screen. And today that's a big problem for them. If you look at Apple's experience inside, even companies they partner with like BMW and Ferrari, it's kind of crappy. But if there's a giant screen and there's nothing safety critical going on it, fire up Netflix, do whatever the hell you want. It is a completely open environment. So for a lot of reasons, A-mod is also what content providers and communications companies want. So it's not going to have a steering wheel. Who can tell me what this is? Good, it's a map. That's right. This is a visualization of the roads of the United States. So every dark line is a road, and every not dark line is not a road. And this is relatively in the middle of the country. So the amount of roads you need to drive on to traverse all of the United States is massive. And when you buy a GM or a Toyota or a BMW, the implicit contract is that your car is going to work on all of these roads. And in fact, at least for now, roads in Canada and Mexico. So you can buy your BMW and drive it anywhere in the North American continent that you want. That's a really hard problem to solve. And it explains why when you hear someone from Daimler say, we think self-driving is something that is solved in 15 to 20 years, I agree. If what you're trying to do is have your 5 Series or your C-Class do this. But having a vehicle do this is an orders of magnitude smaller problem. It's still really hard, but once you solve this, you get 80% of the population of the United States if you just cover the urban areas. So this is called geofencing, the concept that these vehicles will never be able to leave these areas. And once you agree on geofencing, the cost and the the validation profile of your product comes way, way down. And that's really important. So these cars will be geofenced. What about electric? Today, if you buy a car, I'm sad to say, I'm a huge fan of EVs. EVs are more expensive than gas cars for the same functionality. And that will continue to be the case for some time now. It turns out that the reason for this is how many miles you drive it. It is cheaper per mile once you amortize the cost of it. But at 10 or 15,000 miles, we can't do that. It doesn't make sense to buy a Model S based on economics. But if you drove your Model S 30, 40, 50,000 miles, it starts to. And the fun thing about these AMOD cars is they're going to be driving tens or hundreds of thousands of kilometers every single year. So EV won't be something that's driven by regulation or subsidies or anything. It'll be driven by the people operating these networks buying them because they're cheaper. They will make more money if they use EV. So EV will be cheaper, and on the flip side, AMOD is going to drive EV adoption in cities. Forget the fact that cities are probably just going to ban EVs anyway in the next 5 to 10 years, but without that, you don't need the regulation, you don't need the push from government to make EV work in this context. And so finally, who thinks the model on the right is a more scalable model for growing flowers than the model on the left? Yes, absolutely. The idea that you're going to buy a car and then let it go and do errands or make money for you while you're at work, I think is enticing and it kind of sounds cool. It's totally not scalable, or another way to put it is that the first person that does that at a fleet level will drive the price down to the point where it's no longer profitable for you to do it. So the notion that owned cars, cars you buy, are part of a mobility on demand solution for cities is not sustainable in a large economic model. These fleets can buy in bulk, they can charge them all in one place, they can do their own maintenance, they can do predictive maintenance, they have massive advantages, they can profile how many times they crash and negotiate better rates with their insurance companies. No individual has that benefit. And even if a company like Tesla steps up and tries to offer some of those benefits, a well-managed fleet of these vehicles will always find a lower cost point than an individually owned car. To say nothing of the fact that the financing around individually owned cars is really, really bad compared to what these guys do. In fact, these ones, most of these people don't even own their own vehicles. They're bought by banks and REITs and then leased to them. So this model is already understood for Hertz and Avis and everyone else in the world. So great. So when we say AMOD, what we mean is a fleet-managed, geofenced, electric car without a steering wheel that's summoned by an app. And our argument is that this is not just the apex, it is the only solution that operates at scale inside of large city centers, which again is where 75 to 80% of the developed world lives. So if you solve this problem, you solve a massive transportation challenge, and then stuff that we can talk for another talk at Eco by the Bay, all of the massive advantages to parking and congestion and sustainability and energy management and pollution and. There's massive benefits to doing this. I'm going to kind of accelerate through this because I think I'm running out of time. How far have I gone?
You've got about 10 minutes.
10 minutes, oh yeah. Okay, so lots of people are thinking about AMOD. Some people have bad days. Yesterday, Volkswagen launched this, and Verge called it an angry toaster. And Jalopnik called it a a caterpillar from outer space. Anyway, sometimes it doesn't go well. But people are trying. This is my colleagues at IDEO thinking about mobile workplaces on demand. So there's lots of ideas. People are playing with them. Some of them are building concepts. Some of them are building prototypes. You're going to see a lot of this. But today in the marketplace, those things aren't ready. With the exception of Waymo, no one has really built one of these things and driven it around. They're all using production cars. And this is one of the big challenges, is that this car is not a platform for development. It is a highly locked down, embedded, proprietary wasteland of development. And anyone that's tried to build on these has a lot of challenges. And there's lots of companies popping up to help people do this. Some people are taking different approaches. This is Zoox. This should make John Eggert really happy. There's 8 Velodynes, yep. So this is good for the sensor guys. They love this. Some people, Elon says no LiDAR. That makes John unhappy. But But I think there's a lot of people doing tests out in the field in different ways. Some of them are partnering lightly with OEs like Uber and Volvo, and some of them have really, really deep connections like acquisition in the case of Cruise and GM. But the funny thing about this is that if they're going to build an AMOD car, if that's the point of all this work, they're actually doing something that is going to reduce their sales by massive amounts. This is why the car companies are having a bit of a challenge in fully embracing this. That if you have lots of vehicles in these cities that are shared, the number of vehicles people need to put into their driveways drops precipitously, and the total number of cars drops. It might not be 5 to 10, but even if it was a 20% drop in their sales, that would be earth-shattering for any one of these OEs. So this is a big challenge, and they're trying to figure it out. So why is this a big deal? Can anyone identify this awesome city? Yes, thank you, Austin. City, about 890,000 people in the city center, 2 million if you count everybody in the suburbs. So study was done last year, and they said, hey, would you want to use these AMOD services? 41% of the people said, yeah, they would use it at least once a week. 13% said that they would use it all the time at $1 a mile. Now, it costs about 80 cents a mile to operate a vehicle, to own and operate per mile a vehicle yourself in a big city. And that's parking and everything else factored in. So $1 a mile is really, really close to that, and there's a really decent take rate. What's interesting about it is that when you do the math on that, if you achieve that take rate, your net revenue of that service would be bigger than Uber's total net revenue globally in 2015. So this is Austin. Austin has 1/10 as many people as Shanghai. If you look in the United States, the total opportunity for these services is over $100 billion by 2025. Some of it has challenges in that it snows. Sorry, Boston and New York, but it snows and that's hard. But if you just look at Texas alone, over $10 billion opportunity over the next 7 years. So this is really, really interesting, and it pushes us to develop technology that can get there and eventually scale up to the size of a city like Shanghai. So AMOD and AI, this is where the big challenge is, I think, for all of us. It's not a technical talk if there's not an SKCD in your talk, so just to nail that, I'll give you guys a second to read this and appreciate it. So when we talk about self-driving cars, we're sort of missing the point. That's not what these things are. It's not a self-driving vehicle. This is replacing the human component in a vehicle. That's very different. That there are people that are looking at AI on object detection, classification, tracking, agent intentionality, all these great, and we work with companies that do all of this. But those are pieces, very important, but they're pieces of it. That in order to get this to work together, you have to solve a bigger problem. You have to replace the taxi driver, the Uber driver, and all the things that person does. Drive the vehicle, talk to the passengers, talk to other people outside, make sure you haven't passed out in the back, right? There's a lot that the human does. And we do it pretty well, that we have this amazing set of sensors. They're kind of crappy by comparing it to LiDAR. LiDAR's really great, your eyes are not that great. But they're deeply embedded into our system, and there's a lot of distributed processing that happens in a human. And so the notion that you're going to build a brain for a car, I think is really dangerous. I think it underserves, it doesn't describe what you're doing, and it makes it sound like there's going to be an intelligence that just runs the whole car, and everything else is going to be sort of dumb. And that's not the case. That's not the way your body works. It's not the way that any sort of complex system works today, that you wind up distributing, because you have to solve lots of different challenges, and we're really good. It's amazing that human can navigate these types of diverse situations. But when you look at it, this is what we're replacing. And so when you talk about a LiDAR or a camera, you're talking about an embedded sensor that is connected to systems in your body that are processing at multiple levels, some of them completely autonomous, right? This is what's happening. The brain is half of the thing at the top of this. Everything else, the autonomic systems, the sensor systems, motor control, when you pull your hand off a hot stove, your brain didn't have anything to do with that. There are things that happen at low level that are important for us to think about, because we're talking about taking this whole stack and re-representing it in a vehicle. And today, these vehicle systems are deterministic, hard-coded, embedded computers, hundreds of them in some cases in kind of cars. So those systems have very simple APIs, but the idea that, there are sensor companies today that are putting object tracking inside of their sensor. So how do you understand what their object means to your higher level system? And which one do you trust? And how do you negotiate that discussion? The idea you're going to send everything to a central processing unit and do it all there, that's one approach, but it's not the best for latency, it's not the best for reliability, and it's almost certainly not the best for cost. The edge processing and processing along the network and having AI along the way in between the edge, the motor control systems and the sensors, and the centralization is going to be key to making these systems scale. So it's not this. This is a bad metaphor that will, of course, be repeated millions and millions of times in tech press for the next N years. But what's really needed is for people to figure out ways to take components in these systems, low-level systems, networking systems, high-level processing, cloud processing, and figure out how to work together. That it's unlikely there's going to be one central thing that just does everything. It's going to be more distributed than that. It's going to be more brokered than that. And this is when you start thinking about scaling up from 1 car to 1,000 car to fleet of tens of thousands of cars in a place like Shanghai, there's a lot of value in being able to move this information around and share, not just from the vehicle, but from vehicle to vehicle. But there's no framework for this today. The car companies are completely locked down. They're walled gardens. Their embedded systems are completely, unassailable from the outside. And there's also not an understanding of how other companies will work together to solve this problem. And one of our big views on this is that having a bunch of vertically integrated companies plow capital into solving this all by themselves, we've seen that before in Silicon Valley. We see it like once every 10 years, and then it falls apart. And so I'm hoping that it falls apart in this space a lot faster, because I would really like automated mobility on demand. I think it'd be really good for everybody. So we do a lot as a human, and trying to figure out how we represent that in a system is harder than just thinking about it's a computer program running on a PC in a car. And one of the things that we work with are systems that help this. So our platforms shuttle around massive amounts of data. Just to give you an idea, if every car company if every car sold in the US are running our platform, we'd process about 8 times as much data as Facebook does on an annual basis. So this is a, exabyte scale kind of problem. And there are lots of different players that are trying to get at shared data inside of the car. And that's a big problem too, not just from bandwidth and latency, but also security, reliability, and things like that. So these are tough problems. These are the kind of things we're working on. And so we work with companies that are developing AIs in sensors, in networks, and things like that. And we work with our own AI systems as well. And so we entreat you that if you share our vision that AMOD is the future and maybe the best future for transportation, we'd love to talk to you, find out what you're working on, and see if there's ways that we can collaborate. And I think I have 1 minute left, so if there are any questions, I'd love to take them. Thank you. In the back. Sir. Oh.
Okay, one little thing, maybe it's a misunderstanding. You had this example where a self-driving car actually was offered for the cost of $1 per mile, while a self-operated car was cheaper. So my question is, when one of your points was that autonomous car or automated cars are significantly cheaper, why would you offer it for $1 per mile? And why would people use it if it's actually more expensive than owning their own car? I really don't understand the people who say I would use this instead, the cheaper version of it.
Yep. So I don't have the full, that's a great question. So I don't have the slide here, but I'll put it into the PDF. The target right now is actually lower than 80 cents per mile. The study that was done in Austin asked the dollar per mile question, and they got a take rate. I don't think most people know what it costs to operate their own car per mile. Here's a fun fact. If you live 10 miles away from work, how much money did you take out of your retirement by living 10 miles away from work as opposed to working at home? How much money did you lose if you had taken the money for commuting and invested it at kind of standard low return rates for a 30-year career? Answer is $1 million. So people don't make rational decisions in this space. I think the illustration for us was that even at $1 a mile, people were very interested in the service. When you look at the cost curve, the target really is for us to get under 50 cents a mile. We think that 50 cents is what people in the suburbs pay for a Toyota Camry. If you can get below that 50 cents, then it's sky's the limit. Almost everyone will jettison their cars for a mobility solution. But people make really poor rational decisions. Uber drivers are another great example. If you do the long-term analysis of how much your asset is depreciating versus what you're making versus your time, driving for Uber doesn't make sense. Uber's kind of a tax on people that cannot do net present value calculations on their assets. And so I think there are lots of irrational decisions. I think what we're trying to say is there is a really good cost curve to this technology, and the human is 50% of the cost of existing ride-hailing services. So getting that out helps, then managing as a fleet, optimizing the car around not being driven. Each one of these things gets you lower and lower to the point where there's no way an owned vehicle of any configuration will compete on a per mile basis than one of these cars.
Thank you.
Thanks again, appreciate it.
All right, appreciate it.